500 years ago, a mid-level Catholic cleric living in a small Polish town turned the world upside down. His name was Nicholas Copernicus, and he came up with the heliocentric model in cosmology, the idea that the Earth was not the center of the universe, but was moving around the Sun along with the other planets. The book he wrote on this idea, where that part of the idea only occupies 4% of a book that's mostly full of mathematics, was called De Revolutionibus, On the Revolutions. In the modern world, revolutionary refers to violent social and political upheaval, but the modern meaning of that word comes from his book. So his book was not just a book about mathematics and astronomy. It was a book about overturning the culture of the time. Copernicus inherited the ideas of Ptolemy from the ancient world, but he was aware of problems in the Ptolemaic model. It was ugly, clumsy, kludgy, and unnecessarily complicated. He was aware of the retrograde motion of Mars, Jupiter, and Saturn, and realized that if instead of the Earth being at the center, the Sun was at the center, those retrograde motions would go away and be naturally explained. So, he was motivated to think in terms of the Sun as the center of the solar system. He was also aware of simple Greek geometric arguments that made that same case. Copernicus was an official in the Catholic Church, and doctrine of the Catholic Church of the time held, according to several places and statements in the Bible, that the Earth stood still and was not in motion. So by framing this idea, he was going against Catholic and Christian doctrine, and putting himself at risk. As a result, Copernicus took 20 years to write his book and basically sat on it till he was on his deathbed. On his deathbed, he gave his friend Rheticus permission to publish it after he died. Even then, Rheticus wrote an apologetic preface to the book, trying to reassure people that it was just a mathematical model and not the actual truth. Nonetheless, when the book was published, and only a few dozen versions still exist, it did change the world. It made its way into the hands of other thinkers around Europe. Remember, the printing press had been invented less than a century before, so we had the first possibility for the dissemination of scientific knowledge. Previously, this had been done painstakingly by monks in monasteries. Copernicus's book came into the hands of other astronomers, and they recognized the merit and value in his ideas. And so the heliocentric, or sun-centered cosmology took hold. But just as the geocentric model had a fly in the ointment, the retrograde motion of the planets, the heliocentric model had its own problem. And the heliocentric model's problem was the fact that the stars don't vary their brightness and relative positions as the Earth goes round the Sun. Why is this a problem? Well, in the geocentric model, all the planets and all the stars being on a fixed crystalline sphere are at the same distance from the Earth and never vary that distance over a year. So naturally those stars will always have the same brightness regardless of the time of year, and they won't vary in their relative positions. But if you think about the Earth in motion around the Sun relative to more distant stars, then there must be times in the year when the Earth is further and closer to a particular set of stars, giving two effects. Those stars should appear brighter and fainter over the course of a year, and probably more observable, the angles between them, subtended by the Earth, should vary smoothly, going larger and smaller over the course of a year. None of those effects are observed. And so the only way that's explicable in a Copernican model is if the stars are much further away from the Earth than the Earth is from the Sun. So the corollary of a Copernican heliocentric model is a vast universe, far larger than the Greeks had contemplated, far larger than Aristotle contemplated, and far larger than the Church was willing to accept. However, the reason his book was revolutionary was probably not the astronomy. The reason the book was revolutionary was for the cultural dislocation it implied about humans. Remember, the pact between humans and their creator, codified in the Judeo-Christian religions, posits us as the pinnacle of creation and the center of the universe. Of course, the universe should be built around us, and we should be the center. It's unremarkable, not even worthy of comment. Copernicus's idea upsets this cozy relationship between humans and their creator, and implies that we are just on a rocky body orbiting in space, along with other rocky bodies like the moon and the planets. No longer special in the scheme of creation, is a dangerous threat to the cultural ideas of the time, and that's really why Copernicus was reluctant to publish his work. If we look in a little more detail at the issue of the distance to the stars, it becomes a major battleground in this debate between the geocentric and the heliocentric model. Originally, the stars were all imagined by the Greeks to be on a fixed crystalline sphere, but partly because of the ideas of Democritus and others, the Greeks countenanced the idea of a larger universe where the stars might be distributed in three-dimensional space. Even so, the angular displacement of a nearby star relative to a more distant star should be visible. This phenomenon is called parallax. It's easy to witness for yourself. You just have to hold a finger in front of your eyes, in front of your head, and look at it with one eye and then the next, and you'll see the parallax shift relative to a background. That's the same parallax shift you would see when a nearby star is observed from one side of the Earth's orbit and then from the other 6 months later. This angular shift of a nearby relative to a more distant star was not observed by the best observation of the time, once again implying that the universe and even the nearest stars must be extremely large and far away compared to the Earth-Sun distance. So the implication was that the Copernican universe was billions and perhaps many billions of miles across, and this was an uncomfortable truth to swallow. So the Copernican idea was out there. Its merits were out there, and the danger in terms of cultural clash was out there with the Catholic Church. The next major player in this chronology was a man called Tycho Brahe, a Dane. At the time, Denmark was a dominant power, dominant over Sweden and Norway at the time. And Brahe had one of these extraordinary lives where the wheels of fortune span in his favor, at least initially. Brahe was born into poverty, one of, I think, 12 children that survived an even larger family. And as sometimes happened in those days, his father, short of money, decided essentially to sell Brahe to his slightly richer uncle, who didn't have a male heir. And so in a stroke, Brahe transformed his situation as a young man, as a child, from poverty and a pauper to the gentry, living with a rich uncle. A few years later, another stroke of luck. Brahe and his uncle were traveling on a road over a swollen river, where a raging torrent had weakened the bridge. Moments later, the King of Denmark was passing over this bridge and it gave way under his carriage, having been eroded by the river, and Brahe and his uncle were able to rescue the King of Denmark, who in his gratitude gave the uncle vast wealth and tracts of land, and Brahe an island called Fyn off the coast of what is now Sweden to form his own observatory. So in these two fortuitous circumstances, Brahe became the foremost observational astronomer of his age, perhaps of the centuries around him, developing an observatory on his own island, staffed with dozens of people and actually some dwarfs who were used to tend the equipment with the small crawl spaces available. He had a pet moose, and we can imagine this moody and atmospheric island like out of something in Hamlet, where Brahe for 22 years conducted observations every night of the sky. Now that's not a very good part of the world for astronomy, not nearly as good as Arizona where I live, and so he kind of had many clear nights, but over 22 years he was able to gather the most accurate data on the motions of the planets ever taken. Remember, this is before the telescope was invented, so he was using geometric devices that create sight lines where he could measure angular position fairly accurately, to perhaps the precision of about the 10th the width of the moon or a few minutes of arc. Nonetheless, by his careful and systematic observation, he clearly noted the non-uniform motion of the planets beyond the Earth in its orbit, Mars, Jupiter, and Saturn, to a very high degree of precision. And this database became the data set that had to be explained if you wanted to explain planetary motion. Brahe was a brilliant observer, but not a great theorist. He didn't even really believe in the Copernican model. And as he got later in his life, he worried that he wasn't smart enough to make sense of the data he'd taken. So he took on a young assistant, a brilliant mathematician called Johannes Kepler, known to be one of the most brilliant in Europe at the time. But he was jealous of Kepler and wasn't willing to give Kepler his data. And so cat and mouse ensued for several years, Brahe guarding his data and his reputation, but knowing that Kepler had the mathematical savvy to make sense of it. Luckily, Brahe changed his will later in his life and let Kepler inherit his data. By this time, Brahe had already burned a lot of bridges. The King of Denmark was fed up with him. He'd lost his island observatory and was roaming around Europe as an itinerant person, outstaying his welcome and the few people who'd have him. One evening, he was dining in the castle of a duke, and according to the custom of the time, you did not leave the table until the host had had their fill. Now, Brahe was a bon vivant, actually a bigamist, and ate and drank to excess. He'd lost the tip of his nose in a duel, not over a woman, but over who was a better mathematician, and he was a larger-than-life character. So having drunk and eaten to excess, he was very uncomfortable, but the host had not risen, so Brahe had to stay. By the time the host rose and Brahe dashed to his coach and took the rough road, rutted and stony, down the bottom of the mountain, his spleen ruptured, and he died of an infection 3 days later. But luckily, Kepler got his data, and Kepler knew exactly what to do with this treasure trove. The Copernican revolution was an astronomical revolution, a replacement of the geocentric model where the Earth is the center of creation and immobile, and everything goes around us, with the heliocentric model where the universe has to be much larger and the Earth is in motion. But it's more than a scientific revolution, it's a cultural revolution, because it breaks the cozy pact between humans and their creator, thereby leading to conflict between Copernicus and the Catholic Church. Following from Copernicus, Tycho Brahe takes the best set of data which cements the validity of the heliocentric model.